Welcome to the series of Artificial Intelligence. In this video, I'm going to give the idea about AI introduction, intelligence agent, problem solving by searching, beyond classical search, adversarial search, knowledge representation and reasoning, machine learning and probabilistic model, unsupervised and reinforcement learning. Let us start with the AI introduction and intelligent agent. In this video, I'm going to cover important topics and the basic idea about it. Let us start with the definition of AI. AI has four definitions: thinking humanly, that is cognitive modeling; acting humanly, that is performed using Turing test approach; thinking rationally, that is a law of thought; and acting rationally, that is a rational agent approach. Russell highlights the rational agent model as the most practical one. Father of AI. So John McCarthy is regarded as a father of AI. He organized the Dartmouth Conference in 1956 and developed the Lisp programming language, which became widely used in the AI research. There are different foundations disciplines of AI. I have covered over here two. First, mathematics, which provides a logic and probability and algorithm for reasoning. Psychology, which contributes insights into human cognition and learning, inspiring AI system to simulate intelligence. Major milestones in the history of AI. So in 1956, Dartmouth Conference marked the birth of AI, and in 1997, IBM Deep Blue defeated Garry Kasparov, proving machines could outperform the human in the complex tasks. AI applications in healthcare. So AI is used for medical diagnosis by analyzing X-rays and MRI scans for early disease detection. It also assists in drug discovery and personalized treatment. Initial and goal states in the water jug problem with a 4-liter and 3-liter jug. So initial state will be always 0, 0. Both jugs will be empty, and the goal state will be exactly 2 liter of water in the 4-liter jug, that is 2, 0. 2, 1, left is always will be an invalid state in the missionary and cannibal problem, because in this state the cannibals outnumbers missionaries on one side, which would lead to missionaries being eaten and violating the rules. Objectives under the n-queen problem. So to place n-queen on an n by n chessboard such that no two queens attack each other on rows or column or diagonal. There are different components of intelligent agents like sensors, actuators, performance measure, and environment. These defines how the agent perceives and interacts with the world. Simple reflex agent acts only on the current perceived, that is the current input, whereas the model-based reflex agent maintains an internal model of the world and it is useful in the partially observable environment. Let us check the problem solving by searching and beyond classical search. So uninformed search, it explores blindly using only the problem definition, while informed search uses heuristic to guide exploration towards the goal more efficiently. Uninformed search is having number of algorithms like BFS and DFS. BFS stands for breadth first search and DFS stands for depth first search. BFS explores the nodes level by level and it guarantees the shallowest solution, whereas DFS explores one branch deeply before backtracking to other. So BFS always guarantee the finding of shallowest goal node as it perform the search level by level. The first goal found is always the shallowest since all nodes at depth D are checked before moving deeper. There are few drawbacks of DFS algorithm, like DFS may get stuck exploring an infinite branch and fails to find a solution. In deep infinite space, it may take very long to reach the goal. There is a limitation for DFS, so that's why there is one more algorithm, that is a depth limited search. So depth limited search sets a depth cutoff preventing infinite descent. However, it may miss solution that lies beyond the limit. So that's the reason we have the next algorithm, that is the iterative deepening depth first search. So iterative deepening depth first search combines the completeness of BFS with a low memory usage of DFS by gradually increasing the depth limit until the goal is found. UCS, that is a uniform cost search. It expands the node with the lowest cumulative path cost and ensuring the discovery of the least cost solution path. Heuristic. So heuristic is an estimate of cost from a node to the goal. For example, in the 8 puzzle, heuristic can be number of misplaced tiles. Greedy best first search, A-star search and recursive best first search are the some types of informed search. Greedy best first search expands based on only on the heuristic, that is h of n. A-star uses both path cost, that is g of n, as well as heuristic h of n for balanced search. Recursive best first search reduces the memory usage by keeping only one active path and backtracking when necessary, unlike in A-star which stores the entire tree. Let us check the adversarial search, knowledge representation and reasoning. So deterministic algorithm always produces the same output for the same input. Example, binary search follows a fixed procedure. Non-deterministic problem. So job scheduling is a non-deterministic as multiple valid schedules exist. Example, CPU scheduling of multiple tasks. Partially observable environment. In this, the agent cannot access complete state of information. For example, a self-driving car cannot always see the hidden obstacle or the other vehicles. Sensorless problem. So an agent has no percept about the environment. For example, a blind vacuum cleaner that cleans without sensing a dirt. Preference of an online search. So online search is used when environment is unknown or changes. Example, a robo exploring a new maze without a prior knowledge. There are primary limitations of hill climbing algorithm. So hill climbing may get stuck in a local maxima or in plateau or in ridges. For example, a hiker stopping at a small peak instead of a tallest mountain. Local maxima in hill climbing search. So local maxima is a state better than the neighbor but not the global best. For example, small hill will act as a local maxima versus a highest mountain peak, which is the global maxima and your goal. Purpose of min-max algorithm. So min-max algorithm helps to choose the best move by minimizing the opponent advantage. For example, it is used in chess as well as in tic-tac-toe game. Pruning conditions for AI. So under alpha beta search algorithm, pruning is used. A node is pruned if it cannot affect the final decision since the another branch already provides a better outcome. For example, ignoring the extra chess moves when the win is guaranteed. Perfect and imperfect information games. So perfect information, all player knows the full state. For example, the chess game. Imperfect information games where hidden details exist, like the poker game. Let us check machine learning and probabilistic models topic. So parametric model assume fixed parameters. Example, logistic regression algorithm. Non-parametric model adapts with the data size. For example, KNN algorithm. Classification algorithm assigns the inputs to categories. For example, classifying emails as a spam or a not spam. Regression algorithm predicts the continuous value, unlike in classification which predicts the discrete classes. Example of regression is predicting house prices. Decision tree forms a axis parallel boundaries, whereas SVM forms a linear or non-linear boundaries using a hyperplane. The primary objective of bagging is to reduce variance and overfitting by combining model trained on bootstrap samples, for example, random forest. Boosting trains the model sequentially, focusing on error from the previous model. This reduces bias and increase the accuracy. Supervised learning algorithms, if they use the labeled data and example predicting the exam marks, whereas unsupervised learning algorithm finds the pattern in the unlabeled data, for example, customer clustering. Reinforcement learning is a learning by trial and error using rewards and penalty. For example, teaching a robot to walk. under the KNN algorithm is nothing but the number of neighbors used for classification. The small k value is sensitive to the noise, whereas the larger k gives more smoother result. The main assumptions under the naive Bayes theorems are the features are cardinally independent given the class. For example, spam detection assumes word occurrence are independent. Let us check the unsupervised learning and reinforcement learning. Unsupervised learning finds the hidden pattern in the unlabeled data. For example, customer segmentation in marketing. In association mining, these are the 4 definitions which are very important. Support, which is equal to frequency of item set. Confidence, that is a likelihood that rule X implies Y holds when X is present. Lift measures how much more X and Y occurs together than expected. Conviction, it measures how often X occurs without Y. Association rule mining, it finds the interesting relationship among the items. For example, whether bread implies butter in the supermarket cell or not. Clustering is an unsupervised learning algorithm. It groups the unlabeled data, whereas classification is a supervised learning algorithm. It assigns the inputs to the predefined categories. Reinforcement learning, the goal is to maximize the cumulative reward through the interaction. For example, training AI to play video games. Q-learning is a model-free reinforcement learning algorithm that learns the optimal action selection policy using a Q-value function. There are different main components under HMM: states, observation, transition probabilities, emission probabilities, and initial state distribution. Supervised learning algorithm uses a label data, whereas reinforcement learning algorithm learns from trial and error with rewards and penalties. Association rules. So association rule shows the items relationship. For example, milk implies bread, meaning whether milk buyers also buy a bread or not. So this is how we have completed important topics from AI. That's it from my side. Thank you all.